Hello, Mr. Subbu.
Hello, Mark.
How are you?
I am doing good. How are you?
I'm great. Thank you for asking. In fact, I'm here with another question for you.
Please choose yours.
Now, everybody is advising mechanical engineers like me to learn design engineering. What is this design engineering? What should I actually be learning?
Okay. Every time when you come up with a question which sounds simple, but it is actually a difficult question to answer. On that note, we will have to first identify where our interest is in. So, design engineering might be a very common word, but it has various domains inside it. Let us take an example. Automotive engineer, automobiles, cars as an example. You will have to first design a car. Design here means you will have to 3D model a car, outer panels, inner panel, etc. etc. And then you will have to simulate them. These simulations can be of two types. One is FEA. What is FEA? Finite element analysis. What do they do here? Yesteryears, we used to generally produce these cars what you had designed. We proto build them, we produce them, and we break these cars on frontal crash simulations, on rollover test, or rear crash, side impact. We used to intentionally break those cars. But now, on today's technology, we don't have to do them. We can simulate them on the computers. Similarly, yesteryears, for us to understand the aerodynamics of the car, or internal vacuum of the car, or how does it behave, how does the atmosphere inside the car behave, all these things for you to understand, you will have to build the car and then test all these things to understand how it actually works out. But today's technology on the CFD, which is computational fluid dynamics, you don't have to build the car, you can simulate these informations to understand how the car's behavior is. So now for designing you have certain tools like CATIA, SolidWorks and all these things. Knowing them is good. For FEA you have tools like Hypermesh, LSDyna, and for CFD again you have softwares like ANSYS, GTSuite, OpenForm. So these kind of softwares play a critical role in identifying each area respectively. So for design, if it is SolidWorks and CATIA, and for FEA if it is Hypermesh and LSDyna, and for CFD if GTPower, ANSYS and OpenForm, if they play a critical role. These are the softwares which is helping us to understand how our product is going to be when we are producing it. Meaning, you don't have to waste your time, money and energy in producing this vehicle. This is the underlying concept. Now, what you will have to actually learn is, where is your interest on? Are you interested in creating these components using these kind of tools? Or are you interested in validating, meaning simulating these components and understanding the results of the design, what the designers have created? So if you can identify where your interest is in, it would be very apt for you to choose what domain you wanted to go into, which is actually wiser is what I would say. Because sometimes people like designing, sometimes people like validating the design or understanding how the design actually works. So this is what it is. So you will have to first know where your interest is in inside this design on the various domains, and then take that appropriate content for you to pursue further. Hope I've answered your question. Thank you.